making a turbidity meter for third world countries.
Cool. So it's a project you gave them, or
Yes.
they?
Yeah.
Yep.
We came up with an idea. Well, we've got two. We've got one that QUT is coming out for. They're running a master's program around one of our projects, and that was a band for children who are highly anxious or autistic.
Yep.
And what that does is it signals the child, taps the child, uses haptic feedback, tap the child on the wrist to say start practicing biofeedback.
Okay.
It initiates through Bluetooth an app on an iPad, so the app's actually designed in a way that in order for them to win the game, they've got to actually calm themselves down.
Yep.
And the other thing it does is also contact the SCP and let them know that the child's anxious or upset, and they can get in before the child actually loses it, and you have all sorts of issues in the classroom that affect that child's relationship with the other kids and with the teacher. That's one project. This is part of another one. What we're doing is we're building a turbidity meter for third world countries, and we're basing it on solar power, and we're trying to make it as cheaply as possible.
Yep.
So they can just use that. In doing that, it's been an interesting project because initially we thought turbidity was easy, and then we realised no, in actual fact it's very hard. And part of that, out of that
So turbidity is sort of the fogginess of the water, is that it? Or
it's to do with the number of particles in the water.
Okay.
So even though the water might look clear, it still can be turbid.
Yep.
And I mean, there are other things that affect it, like for example, changes in weather. You might get the same sample from the same creek at the same time, and one day it's turbid and the other day it's not because of the change in the weather. And then the discussion became, well, how do we actually know that we're measuring light scatter in water? Because that's one of the measurements of turbidity.
Yep.
And so we looked at making, well, the girls came up with this idea. It's you've got a light sensor in there.
Yep.
And then you've got a, you can't really, I'll take that off, you've got a coloured LED in there.
Yep.
And so they put different coloured LEDs in and then use the light sensor to measure the wavelength.
Yep.
With the light. So that's sort of just...
So how did the girls figure that out?
Well,
just research?
We were talking about it and talking about how you would do it. And we started off with this, which is just a basic blink sketch on the Arduino.
Yeah.
And we have conversations about, well, what can we do? That's how that conversation came about the band, was we were mucking around little bits.
Yep.
And we were turning the lights on and off on the thing and doing it from across the room, and then saying, well, how could we actually use that? Because I always think that if you can come up with a big picture and then narrow it down to the practicals,
yep,
it works better than starting from the practicals and trying to find a big picture.
Yes.
You know,
yep.
So,
and that's the whole design process, beginning with, you know, your big ideas and then narrowing it down. And great.
Yep. And that's essentially what we're doing with these. So they're little light frequency testers, light wavelength testers. And we started with that. We started with the blink sketch, went on to using the I don't have it here, measuring light intensity using those little sensors.
Yep.
And then combining the two, and because you need with a turbidity meter, you need to set it up at right angles, and it's about light scatter in the water. So it's making sure that your actual light that you're using is the right wavelength in order to do that. And the other part of it,
so you get a clear result.
That's right. And the other part of this is, I mean, it's been a big investigation in a sense, because we've been looking at things like, okay, what do the numbers in the serial monitor actually mean? You know, what does this mean? We're looking at these numbers, but what do they actually mean? And how do we know that we're measuring light scatter? You know, and the only way we can do that, obviously, is we try the different LEDs, find out which one that particular sensor picks up most accurately, and then use that and see what the degree of scatter is, or if there's a change, and just change the samples. What we're using is just a piece of PVC pipe.
Yep.
We're putting a blanket around the bottom, because you've got to be able to block out all the light, painting it black inside, etc.
Yep.
And going from there, because we were looking at these and we were saying, look, even with that, if you put your hand over it like that, you can see the change in the serial monitor straight away in terms of what it's recording.
Yep.
So then they went, oh, well, you know, we'll have to paint them. You can see there's a black one up near the phone up the front there.
Yep.
And so that's the new test, and painted it black inside.
And how much time do you have with the students to do this?
At the minute, I do like 2 classes a week. So I do the preps on Monday, and Year 3's Monday and Prep's Tuesday, and then I've got another group, this group, that come down and work with me, and I work with them for the break on Monday, break on Tuesday, and an extra hour now because we're working towards going to UQ for the ICT Young Explorers.
Yep.
And Turbidity Meter is our project, so we're working on that. Yeah.
Fantastic.
And this is what we're using, the Raspberry Pis. We've got the Arduinos and the Pis running them back there.
So you don't have any other computers, this is just a screen, a mouse and a monitor and a Raspberry Pi down there?
That's it. And what we're using that for, the advantage of using that, and we're going to do it, we're going to get 28 of them run a network through here, is that you're going to be disconnected from the network. You don't have any of the issues that I know some schools are having with the Arduinos, with drivers.
Yes.
And you don't have any of the issues with the Raspberry Pi. So you're off network, but we're using PiNet, which is like a server type thing for Raspberry Pis.
Yep.
We're just going to run a little independent of the network. That way the kids can come in, we don't have to worry about the time it takes to log in, all the rest of it. They can just go straight to work.
Yep, fantastic. And you're doing what, Raspberry Pi 2s it looks like?
We've got 2s there, but we're getting a set of 3s.
Yeah, because they've pretty much run out of 2s actually. Trying to get a hold of those.
We've just got a price for a bunch of 3s. We want to use the 3s. We're sort of using them at this point to run Arduino without any of the problems.
Yep.
We haven't really got into using the Pis in terms of what they can do. We're using Python, doing Python programming as well with them. So Python, Arduino, and we use something called fritzing. I don't know if you're familiar.
I haven't heard of that.
Great thing for teachers. I'll show you what fritzing is. This is fritzing. Now, what I use this for is I can put this up on the whiteboard and just wait for it to load. What it allows me to do is it actually allows me to set up boards. So it's got the whole setup. So I can set up a breadboard. I can set up the Arduino next to it.
It's crashed.
And then what they do is they can see what I'm doing there, and then they can do it in the boards themselves.
Yep.
The other part of that is too, what I'm tending to get them to do is I do it on the board, they do it in fritzing as well, and then they use fritzing to set up their boards.
Okay, so they set up their own boards and breadboards and everything else like that as they go along.
Yeah, and they do all the wiring, etc. And they do that off fritzing, and then they've got the copy of fritzing, so they can always refer back to it.
And what were the challenges? I mean, so this is a grade 6 class, is it?
Yes.
Yep. And what were the challenges they experienced when you first started getting into this?
Well, for most of them, I think understanding how how the Arduino worked initially. So we're talking about voltage, and we're talking about, well, what are we measuring when you're measuring using the analog pins? You're measuring voltage. When you're using digital pins, you think of it as a switch on the wall, like on off.
Yep.
And so getting the heads around the difference between those two. The other part of it, and the other challenges were things like, as I said before, you've got numbers coming up on the serial monitor, but understanding what that represents.
Yep.
And can you actually change the sketch in Arduino to fine tune it? In other words, to go, well, I want to get I want more precision. So how do I actually get that?
Yeah.
So those sorts of things. But the key point was, and what I always started from, was that we get those big pictures first. Even like if we're talking about the LED, we start talking about things like, okay, I can make that blink faster. So let's get that blinking at say 60. And see what 60 milliseconds, and see what that looks like. And obviously, it looks like the light's on all the time.
Yep.
And then we talk about, okay, well, how does that feature out there in the world? Where would that be useful? And we talk about street lights and how if you change from LEDs to street lights to LEDs, then you can the light's actually on for part of the time and off for part of the time, so you're saving power. But then there's an issue with that because, for example, cities with a lot of LED light actually change the nocturnal habits of animals that live around the cities. So you've got those other environmental issues related to the LEDs too. So it's sort of a big discussion around those sorts of issues. And then coming back to, okay, well, what's another way of saving power? And then we start talking about, well, using sensors in the light posts. Yep. So the lights go off, car goes up the street, the lights go on and off as they go.
Just like you have in toilets and bathrooms and stuff like that. Yeah.
That's right. And so then it becomes a big talk about sustainability and what sorts of things and how you can use sensors to actually create sustainable scenarios.
Yeah.
Okay, but this is fritzing. With fritzing.
And you find the breadboards are far better than actually any sort of other wiring.
I like these. This is
just
ideal
makes
for
it
students.
life easier for everybody, right?
Yeah, this is ideal for students for two reasons. One is if you have it set up like this, everything's stable, it's easy for them to put the wires in.
Yep.
The other thing is that you've got the little rubber feet on the bottom and you don't have problems with metal or
Did you make these yourself or you bought this?
No, I bought those from Adafruit, I think.
Yep.
But yeah, the benefit of that is, you know, if the kids are using these and then they're metal or anything, they can short them out.
Yep.
So, you know, it's being aware of that. The other part of it is, and to what I'm showing kids, is that you can actually pull that chip out and change the chip, $5 as opposed to $35 for the entire board. So if you stuff it up, you just change the chip.
And have you been do you connect the Raspberry Pi through the GPIO board to the anything yet?
No, we haven't done that yet.
Yep.
That's step 2.
Okay.
We're just up to using the software and getting used to using the software and the Arduinos at this stage. But with this, for example, like I can look at that breadboard there and I can change this down to a half plus. Takes a while to click in. Should do it on my laptop, it's a bit quicker. And that changed that. Now that's the same size as that.
That board, yep.
I can go down here now and I can load the Arduino boards. All the different types of boards and sensors are in here, and then you just drag them out, connect them. The advantage of doing this too is you can actually print that out and it's real size. So in other words, you can get that laid over the top of that and poke the wires through and know exactly where the wires go.
Fantastic. And fritzing's free software, is it?
It is, yeah. Download it off the net. Just drag the board out. Drag the board out. Got it.
As it thinks.
Yeah, takes a while. I'm looking forward to the 3s.
Yeah.
And then same thing, rotate the board. I'll do it, just show you how it goes.
So that's that board that's actually here.
Yes.
Is this one that you're showing on the screen?
That's right. Then I can rotate that round like that. Then I can go down to back to the core, go down, get an LED, drag that out over here. Click the rotate button down the bottom. Put that in the board. And then I can go from my, I'll usually get the blink sketch on 13, so I'll take the wire, positive wire from 13 over here, connect that up.
So this is very much like a design package before they actually do.
It is, yeah.
Fantastic.
And then they can change the colours of those, so you know you get them into the habit of red being power and black being ground.
Yeah.
And you know I use the yellow. I use yellow and white for the digital side, and 2 other colours for the analog. So that way, when I look at the board, I know which way they've got it wired straight away just by looking at it from a distance, rather than having to go over and check which wires they've used. But it's fairly simple. You know, you just drag those out, all the parts out, and drag the resistor out there. Just rotate it, and then connect that up. Actually, I stuffed that up, Control Z. So just connect that up to the bottom. What this allows you to do too very quickly, as you can see, is just lay it out for the student, so then they can go ahead and they can set up the connections themselves. Away you go. Change that to black. Bit pedantic. But yeah,
and so you can run this as a simulation and that will blink, or
no, there are online ones that you can do that with.
Yep.
I just use this simply because I've got all the parts and it's a really easy one and the kids can use it.
Yep.
And once they get the hang of it, it's fairly straightforward. I also use this in PDs to show teachers how to wire up the boards as we're doing it as well. So just it's a nice easy way of doing it. The other part of this is improving too. It doesn't show it on here, but there's a code tab on the ones on Windows, so you can actually put the code in here and upload it to your board as well. So you're not using the Arduino IDE, just use this.
Yep.
Fritzing also run a service behind that where you can do if you go into this part here, PCB part, you can actually create your PCBs, send them the sketch, they'll make the board for you and send it back.
Wow. And where's Fritzing based? Is it a German company? Is that
I think it is.
because it looked like German at the front there.
Yeah. But it's a nice little piece of software, really useful.